Day 449 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again another day, another LeetCode problem where we're doing daily LeetCode problems. And today we have question number 3480, maximize subarrays after removing one conflicting pair. The difficulty level is hard, but don't worry because you already know we're going to keep the solution as simple and easy to understand as possible. But before we get started, y'all, don't forget to like, comment, subscribe, and share. And if you need any new Apple AirPods, go ahead and check out that link in the description so you can get you some. Now let's see what the question says. You are given an integer n which represents an array nums containing the numbers from 1 to n in order. Additionally, you are given a 2D array conflicting pairs where conflicting pairs of I is equal to a, b, or the array a and b indicates that a and b form a conflicting pair. Remove exactly one element from conflicting pairs. Afterwards, count the number of non-empty subarrays of nums which do not contain both A and B for any remaining conflicting pairs. Return the maximum number of subarrays possible after removing exactly one conflicting pair. All right, y'all, so that may seem a little bit confusing at first, so let's go ahead and take a look at these examples just to make sure that we are doing this problem correctly. Now, before we take a look at example 1, let's go through the definition of what a non-empty subarray is. It says a subarray is a contiguous non-empty sequence of elements within an array, meaning it has to be an array of elements in order, right? So let's look down here. This is a subarray. This is a subarray. These could be subarrays, which is 1. This is a subarray, but it cannot be just not in contiguous order, meaning it cannot just go 1 to 3. We cannot delete this 2 and keep it in the same order. That would be a non-contiguous subarray or subsequence. We want a contiguous subsequence, right? So meaning it has to go nums of I, then nums of I plus 1, then nums of I plus 2, then nums of I plus 3, and so on and so on. Now let's look at example 1. In example 1, we have the input the input n equals 4 conflicting pairs equals a 2D array of integers, first array being 2 and 3, second array being 1 and 4. The output is 9. Explanation says we remove 2 and 3 from conflicting pairs. Now conflicting pairs is just equal to 1 and 4 because it says right here, remove exactly one element from conflicting pairs. So we chose to remove this element from conflicting pairs, and now we're just left with this element, this right here. Boom. It says there are 9 subarrays and nums where 1 and 4 do not appear together. They are 1, 2, 3, and 4, 1 and 2, 2 and 3, 3 and 4, 1, 2, and 3, and 2, 3, and 4. The maximum number of subarrays we can achieve after removing one element from conflicting pairs is 9. So just to break this down one step further, we remove this element from conflicting pairs. Now we're left with this. Now with the 1 and 4, we want to find how many subarrays we can create with the numbers 1 through 4 without 1 and 4 being in the same subarray. So as you can see with all these subarrays right here, none of these subarrays have 1 and 4 in the same subarray. As you can see, this one starts at 2 to 4, it doesn't start at 1, and then this one ends at 3, it doesn't end at 4 because 1 and 4 cannot be in the same subarray. Similar, this is 3 and 4, this is 2 and 3, 1 and 2. So as you can see, once again, none of these have the numbers 1 and 4 in the subarray, and there are 9 arrays or subarrays we can create like that when we're just using the elements 1 through 4, and we're using 1 through 4 because n equals 4. So it says right here, the array nums containing numbers 1 through n. So in this case, it would be 1 through 4, and that's where we got this 1 and 4 from. Boom. So now that I hope that makes sense to y'all. So let's go ahead and take a look at example 2. So in example 2, this time n equals 5. Conflicting pairs equals an array of integers. First one being 1 and 2. Next one being 2 and 5. Last one being 3 and 5. Output is 12. So in this case, we remove 1 and 2 from conflicting pairs. Now the conflicting pairs are 2 and 5 and 3 and 5. There are 12 subarrays and nums where 2 and 5 and 3 and 5 do not appear together. So once again, these elements are not allowed to appear in the same subarray, similar to what we did up here. I'm not going to go through all 12 subarrays, but if I did, it would be 12 of them, where we would just have to skip all of the ones that have a 2 and 5 in them and all of the ones that have a 3 and 5 in them. And then the maximum number of subarrays we can achieve after removing one element from conflicting pairs is 12. So I hope that made sense to y'all. And now that we understand the question, let's get into the fun part, the actual solution. Y'all, solution is not that difficult. Let's get into it. Now, the first thing we are going to do is we're going to create a variable which is going to hold all, it's going to be 2 pointers such that LR is conflicting pair, right? So we're going to map out our conflicting pairs by saying, declaring a variable called conflicting, or we could just call it conflict map, and we'll set that equal to in a 2D array of integers. We're going to come outside of those square brackets, open up the parentheses. It's going to be repeating, colon, start with a blank array, comma, count, and we're going to go up to n plus 1. Boom. Then we're going to come underneath that and we're going to build the conflict map from the input pairs. So we're going to say for pair in conflicting pairs. We're going to open up the brackets and we're going to say let A equal pair square bracket 0, comma, come outside the square brackets, comma, B equal pair square bracket 1. Boom. Then we're going to come underneath that. We're going to say let L equal min, open up the parentheses, A comma B. Then we're going to say let R equal max, open up the parentheses, A comma B. Boom. Now each conflict is stored such that we only need to check at R, or the right endpoint. So we're going to come underneath this and we're going to say conflict map square bracket R dot append, open up the parentheses, and we're going to pass in L. Now we're going to come underneath this for loop and we're going to create a variable that tracks the most restrictive conflicts left endpoint. So that variable will say var max left, we'll set that equal to 0. Then we're going to, the second most restrictive left endpoint, we're going to say var second max left. We're going to set that equal to 0. Then we need the count of valid subarrays after applying the current conflict. So we're going to declare a variable called valid subarrays, and we're going to set that equal to 0 to start. And then we need a variable for our potential gain if we remove a specific index. So for that, we declare a variable called gain. We're going to set that equal to, open up the parentheses, it's going to be an array of integers. Open up the parentheses, and we're going to say repeating, colon, 0, comma, count, colon, n plus 1. Boom. Now we need to iterate over all possible right endpoints of subarrays. So for that, we could come underneath this, say for r in 1 dot 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 n. We're going to open up the brackets and we're going to update the most and second most restrictive left endpoints based on the conflicts ending at R. So we're going to say for L in conflict map square bracket R. We're going to come outside of that, open up the brackets, and we're going to say if L is greater than max left, then we're going to open up the brackets again. We're going to say second max left equals max left. Come underneath that, and we're going to set max left equal to 1. Then we're going to say else if. So we come right here and we say else if. We're going to open up the brackets. We're going to say else if L is greater than second max left. Then we open up the brackets. We come right here. Then we open up the brackets and we set second max left equal to 1. So second max left equals 1, just like that. Now the subarrays ending at R must start after max left to be conflict free. So for that, we could come down here. We come right here, and we are going to say valid subarrays plus equals, open up the parentheses, R minus max left. Boom. Now if we remove max left, we could add back the max left minus second max left block subarrays. So we could come right here and we could say gain, open up the square bracket, max left, come outside the square bracket, plus equals, open up the parentheses, max left minus second max left. Just like that. And now we need to return our final result, which is the total valid subarrays plus the best possible gain from removing one index. So to do that, we could just come right here and we could say return valid subarrays plus, open up the parentheses, gain dot max parentheses, then we're gonna say question mark 0. Just like that, y'all. That should be all she wrote. Let's give it a run. Make sure it runs properly before we submit it. Okay, we got the wrong answer. So that means somewhere we are probably, the math isn't mathing. So let's go back and see where we went wrong at with our math. So give me a second, y'all. Let me see if we can figure this out. Okay, y'all. So this is where it's at. Max left should be L. Second max left should be L, not 1. Now let's give it a run, see if that works. And it's accepted. So let's go ahead and submit it. Make sure it's still accepted after we submit it. Let's see. And look at that, y'all. 102 milliseconds beats 100% of users. That's what I'm talking about. That's what I like to see, y'all. So with that being said, make sure you get one more look at the code. This is the top part. This is the bottom part. And yeah, y'all. That being said, I hope y'all learned something today, and I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.